Swayam Prabha. Digital India. Educated India.
Horizontal alignment part 4. Among different design elements, we have already discussed about horizontal curves, the forces acting on a vehicle when a vehicle is negotiating a horizontal curves, the need for super elevation, the basis for design of super elevation under mixed traffic operation, the different approaches as mentioned in ASTO for distribution of E and F, super elevation and side friction factor, and also different methods for attainment of super elevation, their advantages, disadvantages. We have also discussed about the need for providing adequate setback distance and the basis for calculation of setback distance under different conditions. Today, we shall discuss about transition curve. After completing this lesson, the student will be able to understand basic elements and terminologies related to transition control, different terminologies which are commonly used for transition control. The student will be able to understand the need for providing transition curve, why we need to provide transition curve or what are the advantages, and also the basis for using spiral transition curve, why a spiral curve is normally recommended as horizontal transition curve. The student will also be able to understand the IRC approach, Indian Roads Congress approach, for design of the length of transition curve, how the transition curve length is designed as per the approach recommended by the IRC, Indian Roads Congress. Let us start with some common terminologies. We have already discussed that the normal cambered section is like this. Okay. Now, when we are trying to provide super elevation, we gradually turn the outer edge, say assume the method for rotation of pavement with respect to the center line, rotation of the outer edge with respect to the center line. So, over a length we rotate it and you find a cross section when the outer edge is rotated and made level. So, this change is done over a length of curve, and that part is known as tangent runout. So, tangent runout is the length of roadway needed to accomplish a change in outside lane cross slope from normal cross slope as indicated here, this is normal cross slope, to 0. This is the cross slope where the outer edge is flat. So, the slope is 0. So, the length of the curve, suppose if it is done over a length, so that length is known as the tangent runout. Now, further rotation is done to make it uniform. Uniform slope equal to the cross slope of the camber, and then it is further rotated to have the required super elevation. So, this is stage 3 and this is stage 4. Now, this length again this is done, this change is done over a length. So, this length where the outer edge from 0 is rotated to attain the full super elevation as shown here, that length is known as super elevation runoff. So, super elevation runoff is the length of roadway needed to accomplish a change in outside lane cross slope from 0 as shown here to full super elevation or vice versa. So, that is what is known as tangent runout and super elevation runoff. Now, the same thing is shown here in a typical super elevation diagram. This is the tangent portion . So, this is the tangent portion up to this line. So, therefore, the slope is equal to the camber, normal cambered section. After that one, this outer edge is rotated with respect to the center line indicated here by this green line, and at this point the corresponding section looks like this: inner edge equal to slope equal to camber, the outer edge is flat or slope is 0. So, this length from cross section, normal cross section to this cross section where the outer edge is made flat, this length of the road is known as tangent runout. Then from this portion, outer edge further rotated up to this point, and then the complete pavement is rotated with respect to the center line to attain the required super elevation. So, in this case, finally, at the beginning of circular curve, the section looks like this. So, this portion of the length is known as the super elevation runoff. Now, horizontal transition control basically can be done broadly in two different ways: using a transition curve and without using a transition curve. There are two possible ways. anyhow there is a tangent and also a circular curve. Now, there are two types of transition control. One is tangent to curve transition. So, in tangent to curve transition, no transition curve is used in between. It is a tangent and then directly the circular curve. Whereas, in transition curve or spiral curve transition, a transition curve is inserted between the tangent and the circular curve. So, let us see two types of transition control. One is tangent to curve transition. Here transition curve is not used. So, therefore, roadway tangent directly adjoins the main circular curve. The other way, it is basically a transition curve or spiral curve transition, where a transition curve is used between roadway tangent and the main circular curve. We shall now talk about basically tangent, a transition curve or spiral curve transition. Most of our discussions will be around that. Now, what is a transition curve? You know that for a horizontal curve, circular curve, the radius is fixed at any point on the curve. For tangent portion also radius is fixed and this radius is infinity. For a transition curve, the radius changes along the length of the curve. It varies from infinity to a designated radius over the length of the curve. So, if we say that a transition curve in terms of the horizontal alignment, in the context of horizontal alignment, that means inserting a transition curve between a tangent and a circular curve, that means the radius of the transition curve changes from infinity at the tangent point to the radius of the circular curve at the beginning of the circular curve. Now, obviously, for all transition curves, the radius decreases over the length. However, the rate of change of radius, it will depend primarily on the shape or the exact equation of the transition curve. So, for all transition curves, the radius will change over length. However, this rate of change will depend on the shape of the curve, what is the shape that we are using, and also it will depend on the exact equation. Now, let us see what are different types of transition curve. Or first let us see the necessity and then we shall discuss about the different shapes. Now, all of you know we have already discussed the forces which are normally acting on a vehicle when a vehicle is negotiating a horizontal curve. On tangent portion, the centrifugal force is 0 because the radius is infinity. There may be significant amount of centrifugal force, basically W by G into V square by R, that will be the amount of centrifugal force which will act outward, and this value will depend on radius starting from the circular curve. The radius is say RC, radius of the circular curve. Therefore, there will be or there may be a significant amount of centrifugal force depending on the radius of the circular curve, and this is certainly a value which is much higher than 0. So, on tangent the centrifugal force is 0 and on circular curve, it is a finite amount, which is a significant amount rather we can say. Now, just think of a vehicle which is negotiating a circular curve. So, as long as it is on tangent, the centrifugal force is 0. The moment it is on circular curve, there is a significant amount of centrifugal force, and the change is almost sudden because the radius is changing suddenly from infinity to the radius of the circular curve. If a transition curve is used in between, or if a transition curve is inserted in between, then the radius will change gradually from infinity to the radius of the circular curve over a length. Therefore, centrifugal force also will be introduced gradually, and there will be no jerk on vehicle when the vehicle is negotiating a horizontal curve. So, therefore, the first advantage is introduce gradually the centrifugal force between the tangent and the beginning of the circular curve, avoiding a sudden jerk on the vehicle. This is number 1 advantage. Number 2, vehicles are steered manually. Drivers, they will use the steering to turn the vehicle. Now, as long as it is a tangent, there is practically or theoretically there is no need of steering movement, because it is a straight road theoretically, and the moment it is on circular curve, then the wheels are to be turned, making it compatible to the curvature or the radius of the circular curve. Now, this change again cannot be done instantly, because change of direction is also done manually by the driver. So, it is a manual operation. So, therefore, suddenly from the straight to turning the wheels at a required degree, that cannot be done instantly. It has to be done over a length. It is done gradually, and therefore, it is done over a length. And this natural path of driving is also transition. So, if we follow or if we insert a transition curve in between the tangent and the circular curve, then it will be compatible with the natural path of driving, what we can say easy to follow path for drivers. So, a transition curve will ensure a easy to follow path for drivers. Number 3, when a vehicle is negotiating a curve, horizontal curve, there is a possibility of lateral shift and encroachment on adjoining traffic lane. We shall come back to this topic again when we will discuss about the AASHTO guidelines in the subsequent lesson, but there is a possibility of encroachment on adjoining traffic lane. Now, if we provide a transition curve, then that minimizes the possibility of encroachment on adjoining traffic lanes, and thereby tend to promote uniformity in speed. Number 4, you are already familiar about the need and the method of providing super elevation, attainment of super elevation. Now, super elevation or the rotation of pavement from normal cambered section to the required cross slope, making it compatible to the requirement of super elevation, that cannot be done instantaneously. Again, that is to be done over a length. It has to be done gradually. The rotation of pavement also to be done gradually. Therefore, if the transition curve is provided, then this super elevation can be introduced easily over a length of road. So, that is another advantage, number 4. Number 5, also it is required to widen the roads on curves. This part we have not discussed so far, because that will be discussed rather later, but it is necessary to widen the road on curves. Now, that widening like super elevation also should not be done or cannot be done instantaneously. Also, that means that again to be done over a length of road. So, therefore, if we provide transition curve, then that will help us to attain the extra widening over a length of the road and gradually. Last point, also it will improve the aesthetic appearance of the road if a transition curve is introduced. So, if a transition curve is introduced, therefore, that will also improve the aesthetic appearance. So, these are basically the principal advantages of providing transition curve and reasons why we provide transition curve when designing the horizontal alignment. Now, let us see different types of transition curve. You can see that sketch shows different types of transition curve, a cubic parabola, then other two types of curve. The first type of curve, cubic parabola, is shown by the white line. Second type of transition curve is shown by the yellow line, and the spiral type transition curve is shown by the green line. Now, although it is a sketch not to scale, just to show the shape of different types of transition curve, up to deflection angle of about 9 degree, it is found that there is no significant difference in these curves. Basically, all three types of curve, they are nearly similar, there is no significant difference. And in all cases, radius decreases with an increase in length with increase in length. In fact, that is a basic property of transition curve. So, therefore, in all cases radius decreases with an increase in length. However, it may be noted that for transition curve type A and B, as indicated in the sketch, the rate of change of radius and hence the rate of change of centrifugal acceleration is not constant for large deflection angle. Now, what we mean by large deflection angle, because up to deflection angle 9 degree, almost all three types of transition curves, they are very similar. So, for larger deflection angle, the first two types of transition curves, rate of change of radius and hence the rate of change of centrifugal acceleration is not constant. However, for the third type of or type C, that is spiral, radius is inversely proportional to the length and therefore, the rate of change of centrifugal acceleration is uniform throughout the length of curve. This is the property of spiral. So, for only for spiral, for the among the given three types of transition curves, only for spiral radius is inversely proportional to the length and the rate of change of centrifugal acceleration is uniform throughout the length of curve. That is what makes it more acceptable. Now, let us see that what are the requirements for an ideal transition curve. Then we shall be able to justify that why a spiral is more acceptable. Now, ideal shape of transition curve should be such that the rate of introduction of centrifugal force, or in other way rate of change of centrifugal acceleration should be consistent. That is what is a requirement, which indirectly means that the length should be inversely proportional to radius, because if the length is inversely proportional to radius, then rate of introduction of centrifugal force or rate of change of centrifugal acceleration should be consistent. Now, one can clearly see that it is only spiral curve which fulfills the condition of an ideal transition curve, because radius is inversely proportional to length or length is inversely proportional to radius. So, therefore, rate of change of introduction of centrifugal force or rate of change of centrifugal acceleration will be consistent for spiral, which is the requirement for an ideal transition curve. Also, the geometric property of spiral is such that the calculation and setting out the curve in the field is simple and easy, because R is inversely proportional to L or L is inversely proportional to R, that means LR is constant. So, that is the basic equation. So, this geometric property of spiral is such that the calculations and setting out the curve in the field is very simple and easy. Also, it may be noted that spiral transition curve simulates the natural turning path of vehicle. Just now I mentioned that movement or the turning of vehicle is done manually. So, that cannot be done, vehicles cannot be turned at delta time, where delta is close to 0. It takes time to turn the vehicle from straight to a particular angle compatible to the property of the or the radius of the horizontal curve. So, the natural driving path of a vehicle is also a transition curve and it is a spiral transition curve. So, therefore, we are saying that spiral transition curve simulates the natural turning path of a vehicle. Now, for all these advantages, primarily spiral fulfills the condition of an ideal transition curve. Setting out the spiral transition curve in the field is simple, and spiral transition simulates the natural turning path of a vehicle. So, for all these reasons, both Indian Roads Congress guideline, IRC guideline, and AASHTO guideline, American Association of State Highway and Transport Officials, both of them they recommend the use of spiral as horizontal transition curve. Now, let us see the basis for calculation of length of transition curve as normally followed in India or as given in the IRC guideline, Indian Roads Congress guideline. Basically, two aspects are considered, and considering each of the two aspects, the length is calculated and the higher length between the two is adopted for the design purpose. Let us look at the basis. Number 1, based on rate of change of centrifugal acceleration. Based on rate of change of centrifugal acceleration. Now, if Ls is the length of the curve and V is the design speed, then the time taken to traverse transition length Ls in design speed V is nothing but Ls by V, length by speed in a simple manner. Now, T is in second if Ls is in meter, that means length of the transition curve is in meter and the speed of the vehicle is in meter per second. So, if V is in meter per second, Ls, the length of the transition curve is meter, then the time taken to traverse a transition length Ls is nothing but T equal to Ls by V. Now, this maximum centrifugal acceleration, what is the value? It is nothing but V square by R, because centrifugal force is W by G V square by R. Now, what is the maximum centrifugal acceleration? That is V square by R, and R is the maximum centrifugal acceleration is corresponding to this value V square by R, and this is introduced over the transition curve length. That means, this is introduced over a time t. Okay. So, this maximum centrifugal acceleration is introduced in time t, where t is Ls by V, through this transition length Ls. Okay. So, therefore, what is the rate of change of centrifugal acceleration? It is nothing but centrifugal acceleration V square by R, and this is maximum centrifugal acceleration is introduced over a time t. So, it is V square by R t. So, therefore, rate of change of centrifugal acceleration is V square by R divided by t. So, V square by R t, this is the basic equation. Now, if you see this V square by R t, t itself is nothing but Ls by V, this component, because time taken to traverse length Ls with a design speed or with a speed V is nothing but Ls by V. Therefore, V square by R into Ls by V, that is nothing but Vq by Ls R. So, C equal to Vq by Ls R. If V is in meter per second, R is in meter, length of the transition curve is also in meter. Now, if we use V as kilometer per hour instead of meter plus second, then there will be appropriate conversion factor. In that case, C will be 0.0215 Vq by C into Ls. Now, whatever equation we use, this we can calculate the length Ls from this basic equation. Now, Indian Roads Congress specify that guidelines specify that this C value may be calculated using this formula 80 by 75 plus V. So, this is the equation what is used for calculation of the value of C, where C is in meter per second cube and radius is in meter. And IRC also recommends that C value should be between 0.5 to 0.8. So, use this empirical formula, check this limiting limit and take the acceptable value of C, accordingly calculate the value of length of the curve. So, this is based on the first criteria. Now, the second criteria is based on the rate of change of super elevation. Now, super elevation, as we have already discussed, super elevation should be introduced gradually over a length, that is the super elevation runoff also we have defined. So, at certain rate this super elevation should be introduced. Now, when we are talking about rate of change of super elevation, it means the longitudinal grade developed at the pavement edge compared to through grade along the center line. And this rate of change, why we limit it? Because this rate of change should not cause discomfort to travelers or make the road appear unsightly. Considering this aspect, IRC says that there should be an upper limit, there should be a lower limit for the rate of change of super elevation. It should not be done at a rate faster than 1 in 150 for roads in plain and rolling terrain, and the limiting value is 1 in 60 for mountainous and steep terrain. Now, considering this rate of change, whatever curve transition curve length we will obtain, our actual transition curve length should not be lesser than that value. In that case, rate of introduction of super elevation will be faster than this recommended values, which are and which is a situation which is not acceptable. Okay. So, it must not be done at a rate faster than this. So, if we say 1 in 150, if we know the super elevation rate, what is the length, we can calculate accordingly, and it should not be more than that. Obviously, the required length depends on the method of rotation also, because the actual amount of elevation what is to be done for the outer edge, that will depend on the method of rotation of pavement. That means, whether the rotation is with respect to the center line or whether it is the rotation with respect to the inner edge of the pavement. We have discussed both the methods. So, obviously, the amount of super elevation what is to be attained or the amount of elevation what is to be done, that will depend on the method of rotation. Now, based on this rate of change of super elevation, what we have mentioned, it should be 1 in 150 for plain and rolling terrain, 160 for mountainous and steep terrain. Considering that fact, IRC has also given empirical formula. Considering that aspect and Indian standard conditions, these empirical formulas are also sometimes used to check the length of the transition curve. Now, two equations are given, two empirical formulas are given, one for plain and rolling terrain, another for mountainous and steep terrain. For plain and rolling terrain, the equation looks like this: Ls equal to 2.67 V square by Rc. For mountainous and steep terrain, it is 1.0 V square by Rc. These two things are different because acceptable rate of introduction of super elevation is different for plain and rolling terrain and as compared to mountainous and steep terrain. In the first case, it is 1 in 150, in the second case, it is 1 in 60. So, therefore, there are two different empirical formulas. So, these empirical formulas are also sometimes used to check the length of the transition curve, and actual recommended or the design length should be higher than this calculated length. Now, let us quickly see the different elements of a combined circular and transition curve that we have tried to show here. this yellow portion is actually tangent portion, this green lines are transition curves, and the circular curve is shown by the red line. Different elements we have tried to indicate. These things are also available in any standard textbook. Now, in this case, this length of the green line in each case at two ends of the transition circular curve, at both ends of circular curves the transition curves are introduced. So, this is the length which is the length of the transition curve. The red line shows the length of the circular curve. This ES, this distance, this is known as the apex distance. These are the two tangent points, okay, and this is the amount of shift, what is normally designated as S. Okay. So, that is the shift, and okay, and this is the point which is known as horizontal intersection point, because earlier this was one tangent, this was another tangent. So, this is the HIP is also used, horizontal intersection point. So, now let us see some of the other properties also. This delta, this angle delta, this is known as total deviation angle. This angle delta is known as total deviation angle. This theta s here and also at this end, because transition curve okay, is introduced at both ends of circular curve. This theta s is known as deviation angle of transition curve, whereas this angle delta c is known as deviation and central angle of the circular arc. Remember that this red line is the actually circular arc. So, these are some of the elements of a combined transition curve and circular curve. The red portion is actually circular curves, green line shows the transition curves, and these are the tangent points. This is horizontal intersection point. Okay. Now, obviously, all elements can be calculated. There are standard textbook, all these materials are available. I am only mentioning the shift because it is often required to calculate the shift. Now, shift is, as I have indicated, this is the shift. This is nothing but Ls square by 24 RC. So, this is the equation what is commonly used or what is used to calculate the shift. Ls is the length of the transition curve, RC is the radius of the circular curve. So, it is Ls square divided by 24 RC. Now, let us take an example problem. Design the length of transition curve for a two-lane highway. So, it is a two-lane highway having circular curve of 250 meter radius and the design speed is 70 kilometer per hour. So, as per IRC we are doing the calculation. So, we have to calculate it following two different approaches and the higher of those two values is to be taken. Now, based on rate of change of centrifugal acceleration, what is the actual recommended C for that? C is 80 by 75 plus V. This V is nothing but 70 kilometer per hour. So, put that, we calculate V as 0.55. We check that this calculated C is in between 0.5 and 0.8. Therefore, this rate of change of centrifugal acceleration is acceptable. Now, using this calculated C, we calculate the length. Since we are using V in kilometer per hour, so therefore, we are using this formula with conversion factor 0.0215 VQ by CR. V is 70, C we know 0.55 calculated, R is 250 meter radius circular curve. Put that, we calculate is say 53.6 meter, say let us call it as 55 meter. Now, based on allowable rate of change of super elevation, for mixed traffic operation, super elevation is designed considering 75% of the design speed. So, therefore, it is V square by 225 R, as indicated here the calculated value is 0.087, which is more than the permissible value. Because what is the maximum permissible value? Permissible value for super elevation under plain and rolling terrain is 7%. So, that means E acceptable is basically 0.07. So, we have to check it against the side friction factor, taking the original equilibrium equation E plus F equal to V square by 127 R. Earlier we calculated E considering 75% of the design speed. In this case, it is V square by 127 R considering the complete design speed. So, we calculate the F and we find F value required is actually 0.084. Now, permissible F as per side friction factor, as per the practice in India or as per the recommendations of Indian Roads Congress is 0.15. So, it is less than 0.15. So, that means it is acceptable. So, this super elevation 7% super elevation is acceptable. Now, pavement width, let us assume it is 7.5 meter. Therefore, total raise, if we consider total raise of outer edge with respect to center line. So, that means we are assuming that here the pavement is rotated with respect to center line. This is very important. Then in that case, the total raise of outer edge will be this super elevation rate 7% multiplied by B by 2. Why it is B by 2? Because in this case, if capital, this is E by 2 actually, capital E by 2, because the pavement is rotated with respect to center line, therefore, this is E by 2, the raise is also E by 2, okay, because it is rotated with respect to the center line. So, this amount, this raise is nothing but capital E by 2, which is nothing but E into B, okay, E into B by 2. So, therefore, 0.07 into 7.5 by 2, so 0.26 meter. So, what is the length required considering the rate of 1 in 150? It is 0.26 into 150, so 39 meter. So, what is should be the design length? Maximum of this 2 that should be used. So, maximum of this 2 is about 55 meter. Now, we have seen that the transition length, it depends on the design speed, as it was evident in that equation how we have calculated the length of the transition curve. It also depends on the curve radius, circular curve radius, and also because the acceptable values are rate of change of super elevation is 1 in 150 for plain terrain and 1 in 60 for mountainous terrain. Therefore, it depends on the terrain also. So, considering terrain, considering design speed and considering different curve radius, the required length of transition curves under different conditions have also been calculated and given in tabular form in the IRC code. Now, where transition curve cannot be provided for some reasons, for some practical reasons, although we know that it is advantageous to provide transition curve, but if transition curve cannot be provided, then 2/3 of the super elevation will be attained on straight section itself before the start of the circular curve and balance 1/3 on the circular curve itself. So, that way we shall introduce the super elevation, required super elevation, 2/3 before the beginning of the circular curve and 1/3 within the circular curve length. This also will make it compatible with the requirement of drivers and considering the natural path of driving. Now, here are some question sets. What are the advantages of providing transition curves in horizontal alignment? Number 1. Number 2, why spiral is used as an ideal shape of transition curves in horizontal alignment? Number 3, explain the basis for calculation of the length of horizontal curves as per the recommendations of Indian Roads Congress. Try to answer these questions. Now, let me try to answer the questions of lessons 3.9. The first question was, explain various stages and alternative approaches for attainment of super elevation. Basically, there are two stages. First stage is elimination of crown of cambered section. This is the normal cambered section. So, first stage is to have uniform slope equal to camber, that was elimination of the crown of cambered section. This is the first stage. Then further rotation of pavement to attain the full super elevation. So, this line is rotated again further to have the required super elevation. Now, the first stage can be done in two alternative methods approaches. Outer edge is rotated about the crown, keeping this point constant, the outer edge is gradually rotated like this. So, here the disadvantage is that lesser slope, cross slope lesser than the required camber. So, there could be the drainage problem for a small portion where the slope is lesser than the camber. So, alternative approach is shift the crown gradually. Okay. So, that was the another thing, but here there will not be any drainage problem, but there will be negative super elevation and also the crown is shifted. So, vehicles have a tendency to follow the crown. So, it may not be very convenient considering the safety. The second, so each method had its own advantage and disadvantage. The second stage is rotation of pavement to attain full super elevation. That means, after removing the crown, we have uniform section like this. Okay. So, now to have required super elevation, this is to be rotated. Now, this can be rotated with respect to center line, that is the first method. Okay. Rotation about the center line. So, maybe making it like this. So, in that case, okay, the earthwork is balanced, but the lower edge or the inner edge is depressed. So, there could be drainage problem in this area. So, the second method is rotation about the inner edge. So, we fix the inner edge and then rotate the pavement to have the required super elevation. So, here the center line, vertical profile of the center line is also changed. Okay. So, that is another disadvantages, and earthwork is also not balanced. Sometimes there is another method which is also followed in a limited way, rotation about the outer edge for a given special situation, and each method has its own advantages and disadvantages. So, site specific decisions are to be made. Now, the next question was, define curve resistance. This was not discussed, but I thought you should try to answer to this question because it is already known to you. Automobiles are steered by turning the front wheels. So, the movement is something like this. So, these are the wheels which are maybe turned like this to negotiate a curve. Okay. Now, vehicles which are driven by the rear wheels, okay, on horizontal curves, the direction of rotation of rear and front wheels are different, because rear wheels are like this. Okay. So, front wheels are only rotated. So, what is happening? The tractive force what is given by the rear wheel is actually T, say this is T, which is given by the rear wheels, but tractive force which is available in the direction of movement is nothing but this is making it compatible with this direction. So, this is nothing but T cos alpha if this turning angle is alpha. Okay. So, the whole T is not available in the direction of movement, it is only the T cos alpha, that amount is available in the direction of movement. So, what is happening? It is basically because of this curve, this is happening. So, there is a loss of tractive force. What is that amount? That is amount is T minus T cos alpha or T into 1 minus cos alpha, which is a function of the turning angle alpha. Okay. So, that means this is happening only in curve. So, as if because of the curve this amount of loss is occurring. So, therefore, this is known as curve resistance. So, curve resistance is nothing but loss of tractive force due to turning of vehicles on horizontal curves. Now, obviously, for vehicles with front driving wheels, this problem does not exist, and it will be severe for heavy vehicles, because most of the heavy vehicles they have rear driving wheels. So, therefore, more curve resistance on sharper curves, because this angle alpha will be different, because it depends on alpha. So, alpha is more for sharper curves. So, there is more curve resistance. Also, it is worthwhile to mention that this problem of curve resistance is acute on hill roads, because it is not only the sharp horizontal curves, but also there are steep gradients. So, the problem becomes more acute for hill roads. How to consider this aspect in design? We shall come back to this topic when we will talk about the vertical alignment. Okay? There is something called grade compensation. So, that topic we will discuss. Now, the last question was calculate setback distance for radius of curve 400 meter, length of horizontal curve 200 meter, required side distance 300 meter. So, here you can see very clearly that this is a case where the required side distance is basically more than the length of the curve. Length of the curve. So, what is happening in this case, alpha by 2 can be considered as 180 L by 2 pi r minus t. So, it is calculated as 14.39. Okay. It is 14.39. Next, in this case, you can see the setback distance is nothing but Cf. This can be calculated as Cg plus the Gf. Now, what is the Cg? Cg is nothing but OB is r minus d, OC is r. So, OC minus OG. Now, what is OG? OG is nothing but OB sin alpha by 2, so OB cos alpha by 2. So, that means Cg is nothing but r minus d cos alpha by 2 plus, if we have to calculate the total setback distance, this Gf component to be added. Now, Gf is nothing but S minus L by 2, which is nothing but AB sin alpha by 2. So, that is what is added. We have already discussed the theoretical basis for that.